This video is going to help us review for our Module 9 test that we will be taking tomorrow. So be sure to follow along and do these problems with me so that you can practice for our test. If you are stuck on any of them or not sure why we are doing that, then please let me know so we can set up a time to meet before you take your test. So on these ones, we are going to solve for the variable. So this says y, and remember this line means to divide, y divided by 7. So we want to do the opposite to both sides. The opposite of divide is to multiply. So when we take 1/7 and we times by 7, that cancels that out on that side. So now we need to do the same thing to the other side, times by 7, times by 7. So here we have 42. 49 plus 4 is 53. 14 plus 5 is 19. So I am saying that y equals 1,932. It's a good idea to plug it back in and check. So this problem says that 1,932 divided by 7 should equal 276. So it goes in here 2 times, which is 14. 5 left over goes in there 7 times, which is 49. And then there are 4 left over with a 2 brought down, and 6, 276. So this is the solution for y. So here we have 7g. So what does 7g mean? That means 7 times g. The opposite of timesing is dividing. So we want to divide by 7, divide by 7 on both sides. So all we're left with is g, because 7 divided by 7 is 1, and we just want 1g. So now we need to do 91 divided by 7. So go ahead and try that. So here we have 1 time, and there's 21 and 3. So I am saying that g equals 13. I'm going to plug it back in and do 7 times 13 to double check myself. 7 times 3, 21, 7, 8, 9. So g equals 13 is the correct solution there. Here we have r plus 1,295 equals 8,001. So I need to do the opposite of a positive 1,295 and get rid of that on this side. So I'm going to take them away. That means I'll take them the same thing away on this side to keep it balanced. So these ones cancel out. So I'm just left with r equals 1 minus 5 I can't do. So I can borrow, can't borrow here, but we can here. That becomes 7. And I borrow here and it becomes 10, and I give it away and becomes 9. Now I have 10 here, borrow again, and now I have 11 minus 5. 11 minus 5 is 6. 9 minus 9 is 0. 9 minus 2 is 7, and 7 minus 1 is 6. So r equals 6,706. So I'm going to plug that in, 6,706 plus 1,295, and just double check. There's 11 and 10, 7, 8, 9, 10, and 8, 8,001. So that is the correct solution for r. Here we have w minus 6.1. So we want to get rid of this 6.1. So we're going to add on 6.1 and do that to both sides to keep it balanced. When we add with decimals or subtract with decimals, we need to line those numbers up. So here's 6.1, and then this is a 0 here. So 8 plus 0 is 8. 9 plus 1 is 10. 6 and 1 is 7. Plus 7 is 14. And 2. So I have 24.08. So W, because this canceled out, equals 24.08. So I'm going to plug in W, 24.08, and subtract 6. Oops, I did not line up my decimal there. Subtract 6.1. So notice my decimals are lined up. My ones are lined up. My tenths are lined up. So here's 0 here. 8 minus 0 is 8. 0 minus 1 we can't do, so we come borrow. 10 minus 1 is 9. We can't do that. So we borrow. 13 minus 6 is 7. And 1, my decimal comes straight down, 17.98. So 24.08 or 800ths is the solution to W. So remember, every time identify what did they do and do the opposite to both sides. Okay, we're going to try a couple harder ones here, and let's see if we can think through some of these. So this says 18 divided by y. So I need to get y all by itself. 18, we're not dividing by 18, we have 18. So let's take a look here. So the opposite of divide by y is to times by y on both sides. So now I have 18 equals 6y. So I'm still looking to get, so all we did was we moved it over. So we've got to follow our order of operations still. And we can't just times by 18 because that's going to give us a bigger number if we did 6 times 18. And 18 divided by a bigger number would not equal 6. So we move y over by doing the opposite. Now I can get y alone because this means 6 times y. So we're going to divide by 6 on both sides. So this one cancels out. 6 divided by 6 is 1y. 18 divided by 6 is 3y's. So let's plug that back in and see if that fits into our problem here. 18 divided by 3 is 6. 3, 6, 9, 12, 15, 18. It's exactly 6. So yes, 3 is y. Y is 3. So this one was pretty simple. That I think we could just think about that fact family. 18 divided by what is 6? We know, or I can ask 6 times what is 18. There's that fact family there. But it works because we're moving y to the other side, keeping it balanced, and then we're moving the 6 and doing the same thing to both sides. So we did the same thing on y, same thing on 6 until we get y all by itself. Okay, let's try this one here. 3/4 h equals 4/9. So we have all the numbers here. We have this coefficient of 3/4. And we have 3/4 of h. We have 3/4 times h. So to undo multiplication, we divide by 3/4. So 3/4 divided by 3/4 is 1/1. We have 1h left. Now we need to do the same thing over here. Remember, it's got to go all the way to the back. So 4/9 divided by 3/4. It's got to go all the way to the back. So I can't do 4 divided by 3 very easily or 9 divided by 4 very easily. So here, right, I could divide 3 and 3, 4 and 4. Those were nice compatible numbers. Here we don't have them. So I'm going to do the opposite, the reciprocal, and multiply because multiplying can be easier than dividing. So I need to copy this first one, multiply, dot, and do the inverse or the flop of the second one. That means 4 goes on top and 3 goes on the bottom here. So, oh, that was not a 3, was it? Let's see, where's my eraser? So 3 goes on the bottom here. So I can't cancel anything either direction. So 4 times 4 is 16. 9 times 3 is 27. So let's see if there is anything else that can go into 16 and 27. So I'm thinking of some factors of 16, 1 and 16, 2 and 8, 4 and 4. So 16 can't go into 27. Neither can 8, neither can 4, neither can 2. So 16/27 is as simplified as that can go. So when I take 3/4 and times that by 16/27, that equals 4/9. Let's plug that back in and double check. So 3/4 of 16/27. Oh, I noticed some nice simplifying we can do here. So 4 is a factor of 4 and 16, 1 time, 4 times. 3 is a factor of 3 and 27, 1 time, and 9 times. 1 times 4 is 4. 1 times 9 is 9. We ended up with 4/9. So remember, when we have a number right in front of a variable, even if it's a fraction, that means to multiply. So if we need to get the variable by itself, we divide to both sides. That means bring it all the way back behind and then copy dot flop to find the reciprocal, which is the same equation there. Okay, let's look at this one here. So this says 57 minus n. So we have a negative n here. So let's just take a look here. So this is a positive 57. If I did a minus 57, that is not really going to work out for what we want. That is going to give us a negative number. And when I have a negative, that means we're actually adding, and this is just not going to work if I'm taking away a smaller number. So if I'm here at 57 and I take away a negative number, right? It's just not going to be what we want it to be. So let's think about this. How could we make this n positive? So there's a couple ways that we could do this. We could rewrite our equation to make a new fact family, or we can make the n positive by moving it to the other side. So I want to cancel this n out. That means over here, I'm going to add on an n. So I had a negative n, I added one on, these canceled out. Now I have 0 n's here. So I have 57 equals 32 plus an n. Now I have that positive n. So I always like to try and work with positive variables. So if they're negative, we need to think about what can we do to make it positive. So here, this fact family, if I take these two add-ins, here's my sum, which is the total. So, and I could do n plus 32 because of that commutative property. So now I want to get n by itself and get rid of these 32. So I'm going to take them away from both sides. So these ones cancel out. So I'm just left with n. 7 minus 2 is 5. 5 minus 3 is 2. So let's go plug this back in and see if this works here. So let me get rid of this so I can see my problem. So I have 57, and we're going to take away n is 25. So 7 minus 5 is 2. 5 minus 2 is 3. 32. So just think about, plug it back in. Does it make sense? If it doesn't give you the same answer when you plug it back in, try something different. I know I could rewrite this problem and say, these are the things I need to add together. So I'm going to add these, and that's going to equal 57. So every equation has more than one way that you can write it and still be equivalent and mean the same thing. Hey, Andy had $37. She spent $18.57 at the grocery store. What equation can be used to find out how much money Andy still has? So I'm hearing this was what she started with. This was her total. And she got rid of this much money. How much money does she still have? So again, there are lots of ways we can write this. We can say she had $37. She spent $18.57. And that will tell me how much money she has. So I want to see if you can write that equation in a different way and still come up with the same answer. So we could say she has $37 and we're going to take away M, and that will leave us with the amount that she spent. We could also take the money she spent. We could add on the money that she had, and that will tell us how much money she had total to start with. So all three of these are going to give us the same thing here. So here we would do 37 minus 18.5. So here we would have to bring our M, just like we talked about, just barely to the other side and make it positive. So we'd add M to both sides. Then when I would have to, so now it looks exactly like this one. When I bring it to the other side, I have 1857 plus M. So to get M by itself, we minus, which is what we did here. We minused. All of these are exactly the same. And if you're writing one of them, if I asked you to write one, I would take any of these. So it needed 37, 1857, and it needed that variable to show what we're looking for. So this one just says the equation. It doesn't even ask us to solve. So pay attention to your directions. Do you need the equation? Do you need the solution? Do you need both? Hey, the second problem here says Fallon delivered newspapers to his neighborhood. His route included 7 streets. On each street, 6 houses receive the paper. What equation can be used to find out how many houses H he delivers newspapers to? So lots of ways we can do this problem here. So we can say, right, he has 7 streets. They each have 6 houses. This is his total number of houses. So I'm hearing that this is our total. H is the total. So if I do the opposite of multiply, I can take my total. Here's all my newspapers. I could divide it by the 7 streets to give 6 on each street. I could take the total papers, H. We could divide it by the 6 houses, and that would tell us that we have 7 streets. So all of these are going to give us the same answer here, which I can see is 7 times 6 is 42. 42 divided by 7 is 6. 42 divided by 6 is 7. But it wanted us to use H as our total. So here we took 7 streets with 6 houses each, made our total houses. Here we took the total houses, divided by 7 streets, gave us 6 per street. Here we took all the houses, divided by 6 on a street, gives us 7 streets. So all 3 of these are going to be the same problem that are going to give us the same answer. Hey, here we have that Hattie earned $28 babysitting for 2 families. So she did family 1, family 2. She's earning a total of $28. This is her total here. She earned $16 at the first house. I'm going to plug that into house 1. I want to write 3 separate equations, 3 equivalent equations to show how much money M she earned at the second house. So we are looking for this M here. So she had $16 from the first house. She got M and it equals 28. What operation would we put here? She had the first house, the second house. We're putting them together to get a total of 28. This would be an addition problem. We could also flip all of this around. We could say 28 equals m plus 16, use that commutative property. I could even say this was the second house, here's my first house, and she got $28. We could also, the opposite of add is to subtract. So we could take our total and I could take away the money she earned at the first house, and that would tell me the money she earned at the second house, which if I found m all by itself is what I would be doing. I would have to take this 16 away from both sides. M equals 28 minus 16. I could also, another way, take my total. I could minus the money from the second house, and that would leave me with 16. So all of these, so we actually wrote 4 equations that are the same. So if it was adding, then you can always flip it and make it subtracting. And opposite, subtract can always turn into add. Multiply problems can always turn into divide. Divide can always turn into multiply because they're just opposites of each other. Hey, we are going to solve and graph these. So these are just equations. So notice, right, they just have an equal sign. So I just need to put a dot to say this is the only answer. We don't have a whole solution set. We just have one specific answer that will be our variable. So 9x means 9 times x. So see if you can do the same thing to both sides to undo 9 times x. So we would want to divide by 9 on both sides. So these cancel out. 9 divided by 9 is 1x. 72 divided by 9 is 8. So x equals 8. Plug it back into check. 9 times 8 is 72. So I'm just going to graph that x equals 8. So I'm going to put a dot there and say that is x. Here we have w minus 4 equals 3. So I need to get w by itself. So I have negative 4. So I want to balance that out to 0. So I'm going to add on 4. But I have to do it to both sides to keep it balanced. So this is 0. So w equals 7. So I'll just come down here, graph that, and say this is w. So we're not having to see which way the arrow goes because it just equals. That's the only thing, w is 7, that is going to make that be true. Hey, our next problem says that a garden had a total of 54 square feet. So I'm going to draw my rectangle here. Sorry, I didn't say that. I should add that. That is a rectangular garden. Okay, so we have this rectangular garden. 54 square feet is what is on the inside. So 54 feet square. The garden was 3 feet long. So we want to write an equation that can be used to find the width of this garden here. So when we are doing area, see if you can remember the formula for a rectangle when we're doing area. We take the length, we times it by the width, and that equals the area. So what things do we know here? We know the area is 54, so we can replace the area with 54. We know the length is 3, so I can replace the length. And we're looking for the W. So I can say 3 W's equals 54. Now it wants us, so this one, we wrote our equation. Now it asks us to solve. So we have to do the opposite of 3 W's. So 3 times W, the opposite of times is divide. So I want to divide by 3 on both sides. So here's my new problem. So these cancel out to 1. 3 divided by 3 is 1 W. So over here, I'm going to do 54 divided by 3. Goes in there 1 time, which is 3. And 2 left over, bring down my 4, goes in there exactly 8 times. So the width of my garden is 18 feet. So they have a long, narrow garden. And if I plug that back in, 3 times 18 is 54. So that would make sense there. Okay, so we're going to move on into the inequality part of our review. So the previous has all been equations. They all have a set value that they have to equal. So now we're going to talk about those inequalities when we compare, and they can have an infinite amount of solutions. So the first one just asks us to write a solution set for B. So I want you to stop and think about what are 3 things a solution set should include, at least 3, just for good proof. So B is greater than 4.2. So I want you to see if you can think of 3 things that are greater than 4.2. So can it be 4.2? No, we don't have that equal sign. So I could say 4.3 is bigger. I could say 5 is bigger. I could say 6.7 is bigger. So it doesn't matter what you put in your solution set as long as it's following the rule in your inequality. So all of these should be bigger, bigger, bigger than 4.2. So I notice, right, this is a positive number and I needed something bigger. None of my answers in my solution set could be negative for this particular inequality. Okay, next we are going to circle all of the values that make the inequality V is less than or equal to 16.5 true. So we want V, all of these, to be smaller or equal to 16.5. So one good thing to do is just, if you have decimals, line up your decimals, write it above there. Think about it. So I want it to be smaller. So same, smaller. So that one is true. So here I have 16.5, same, oh, that's bigger. So that is not going to make that be true. 17 is not smaller than 16.5. So 17.99, well, if 17 can't, then 17.99 can't. So I want you to go through and see if you can find the rest of them and then come back and let's check. So here we have 16.5 and 12.4. So smaller, 12 is smaller than 6. So this one, 12.4 is true. Negative 16.5. So I'm noticing, right, they're exactly the same numbers, but this is all the way to the left of 0. So that is good, right? We want numbers to the left. That's to the left of 0. This is to the right of 0. So it's definitely to the right. Hey, here we have 16.9. So the 1's good, 6 is good, but 9 is bigger. So that is not true. It's close. 16.9, 16.5. It's like 40 cents difference, but this is still bigger. Hey, just 16. So if we have 16.5, this is like 16.0. So yes, 16 is smaller than 16 and a half. 16.6. So let's line up our 16.5. So same, but 16.6 is bigger. So no. 16.5. Oh, these are exactly the same. Can it equal it? Yes, it says it can equal it. So that is the biggest it can possibly be is 16.5, and then it has to be smaller. 3.2, yes, 3 is smaller than 16. 16.51. So let's think about this. Let's add that 0 here. So I want 16.5 to be the biggest, and 51 cents is bigger, so this is not true. And here we have negative 17. We've already decided anything on the negatives is to the left. So yes, that is true. So go through and think about each one. Does it make your inequality true? Hey, Taysha's pets all weigh at least 3 pounds. So let's ask ourselves some questions here. Does one of her pets weigh 5 pounds? They could. That's more, okay, right? At least 3. The smallest they can be is 3. Does she have a pet that weighs 1 pound? No. Could she have a pet that weighs 4 pounds? Yes, that's at least 3 pounds. Can she have a pet that weighs 3 pounds? Is that at least 3? Yes, so it could equal 3. So first we're going to write an inequality to show how many pounds P her animals weigh. So we're going to take P, and these are her pets in pounds, and her pets have to weigh at least this. They've got to weigh more than this. So my pets have to weigh more than 3. But could it weigh 3? We decided yes, it could. So I also need that equal sign. I know sometimes I want to say that, oh yeah, my pets, and I think 3, they've got to weigh at least 3. But this is saying her pets are less than 3, and that is not true. So go back and read. Does it make sense? My pets are at least 3 pounds. That means they're bigger than 3 pounds. My pets are bigger than 3 pounds or equal to it. So go ahead and write out a solution set, even if it doesn't ask you to. When you're graphing, I think it's a great idea to put your solution set so you know which way your arrow should go. So think of 3 things that are greater than or equal to 3. So I hope the first one you put was 3. She could have a pet that weighs exactly 3 pounds because that's at least 3 pounds. She can't have a pet that weighs 2.99 pounds. That is not big enough. So she could have a pet that weighs 7 pounds. She could have a pet that weighs 9 pounds. So I'm going to just quickly put those on my number line so I can think about which way my arrow will go. So I'm comparing to 3. So I come and put a big circle on 3. So notice we have a dot in there. So do we need to trap that in there? Yes, because it's in there. And we've got this equal sign, right? The garage door, boom, goes to the ground. It's shut and closed. Trap that in there so it includes 3. And then I go to the direction of my dots or anything bigger than that. Hey, Ryan loves corn dogs, but his mom told him he cannot have more than 10 per week. So he cannot have more than 10. So can he have 8 corn dogs in a week? Yes. Can he have 11? No, that's more than 10. Can he have 10? Yes, that's not more than 10. That's exactly 10. So I'm hearing we need an equal sign as part of our inequality. So we're going to write an inequality to show how many corn dogs C Ryan can eat each week. So we know we're comparing 10 and C. So here's the corn dogs. And I know it can't be bigger than 10. The corn dogs has to be smaller. So corn dogs is smaller. And it could be 10. You just can't eat more than 10. So we can't even eat 10 in a bite of another one. That's more than 10. Can't eat 11. That's more than 10. Can't even eat 10 and a half. Okay. He could eat 10 because that's not more. That's exactly. He could eat 9, 8, any of those. So go ahead and create a solution set. And so create a solution set. So anything less than or equal to 10. So I hope the first one you thought of was 10. He can eat exactly 10 corn dogs. He could eat 7 corn dogs. He could eat 3 corn dogs. So in this case, it probably won't go into the negatives. You don't often eat negative amounts of food. So, but just for showing this inequality, so here we're comparing to 10. Oh, let me graph these. So I said he could eat 3 or 7 or 10. So I'm going to come and I'm comparing to 10. I put a big open circle and I've got this 10 inside of it. And I need to shut that garage door and trap it in there. So we fill it in and connect our dots. And his goes to the left because he can eat less than that. Asher, whoops, forgot a word in here, earns more than $5 each time he mows the lawn. He earns more than 5. So could he earn $7? Yes, that's more than 5. What about $3? No, that's less than 5. Could he earn $6? Yes. What about $5.50? Yes, that's more than 5. Could he earn $5? No, because it says here he earns more than 5. And 5 is equal to 5. He has to earn more than 5. So we do not want an equal sign in this inequality. So write an inequality to show how much money Asher makes. So M, when he mows the lawn, at least he makes more than $5, not at least $5. That could say he could earn $5. He earns more than 5. The money he earns is greater than $5. So go ahead and write a solution set for the money he could earn. So probably depending, on the size of the lawn, but he always charges more than $5. So he can't earn $5. He could earn $5.50. He could earn $6. He could earn $10. So I'm going to put these on here. So 5.5, 6, 10. So I'm comparing to 5. So I come and I circle my 5. Notice nothing's in there. I don't have anything to trap in. The garage door is not closed. It's open. So I keep that open, connect my dots. So he's going to earn more than 5. So anything to the right of 5 is a solution to his inequality. Okay, we want to place an X in the table to show the solution that will make each inequality true. So here we have 32 divided by X is 4. So remember, this is dividing by X. So the opposite of divide by, we have to leave this 32 alone until we do something with the X. We have to divide here. This is our total. So we're going to times by X on both sides. So now I have 4X. Now I want to get X alone. So these cancel it out. So we're going to divide by 4. Divide by 4. 32 divided by 4 is 8. So this one is this. I could also, if that is confusing, to move the X and then do the next step, try plugging each one in. X equals 4. 32 divided by 4 is not 4. 32 divided by 7 is like 4 points something. So that's close, but not the right answer. And here, 32 divided by 8 is 4. So we could just plug these in, and that will help us find our answers. So here, let's try 7 times 4, 28, right? Or I could just undo it. Divide by 7, divide by 7. 28 divided by 7 is 4. So that first one we tried was the right answer. Let's just double check, right? 7 times 7 is 49. 7 times 8 is 56. So the only one that is true is X equals 4. So just because there's one left, don't just plug it in there. There could be one that we don't use a 7 on. So let's go and check ourselves. So here we want to get the opposite of -3 is to add 3. Add 3. So 4 plus 3, yes, this one is 7, but double check and prove your work instead of just guessing. Okay, and that is everything for our review. So if there were any of those that you are confused on, please let me know and we can set up a time to meet before you take your quiz.